Good morning, good afternoon, or good evening, depending on where you are, and welcome to this TechStrong Learning Experience brought to you by the AI Infrastructure Alliance. Now, we've got an exciting program ahead, but first I do have a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, and perhaps you'd like to share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you look to the right side of your screen, you'll notice there are a couple of options for you to engage with our panel. The first of which is the chat tab. So go ahead and start warming that up for me right now by letting us know where you are joining us from. Right next to that chat tab, you'll see a Q&A tab. So feel free to send any questions you may have there, and we'll address those throughout our program. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around. The topic of our discussion today is building the perfect data set. And I'm joined by Lee Baker, General Secretary at the AI Infrastructure Alliance, Zach Winthy, CDP Product Evangelist at Treasure Data, Misha Solpovar, Vice President of AI Product at Cherry, Francesco Iorio, CEO at Augmenta, and our very own Mike Vazard, Chief Content Officer here at TechStrong Group. So Lee, Zach, Misha, Francesco, and Mike, thank you all so much for being here with me today. Mike, do you want to go ahead and get this conversation rolling?
Yeah, well, thanks everybody for joining us. We're going to be talking about challenges with AI and what it takes to build the data sets to drive these models. And I guess I'm going to defer to Lee for the first question here and see where that goes from here. But Lee, good to see you as always. And folks, here we go.
Very good, Mike. Thank you, and thank you to the TechStrong team. Guys, thank you for your time today. Let's kick this off because we can talk about data as a first-class citizen, or we can talk about data centrism, or we can talk about data as a primary asset. But Misha, help me out. What are we talking about in terms of a distinction between traditional modeling and data-centric AI?
Yeah, thanks for that question. It's a great one. We've been putting together data science teams for a long time, and we failed a lot of projects, right? And issues happen when you focus too much, I think, on the modeling bits rather than on the data sets. And over time, we've learned that really having a data-centric view is key to success, right? And so one of the things we're trying to do at Cherry above all else is create not just kind of robustness that's domain specific and domain tested, model ready, but also create flexibility in the way that you expand and evolve to that perfect data set. And so by really shifting focus from the model to the data and the curation of data, and how you do that over time to get better and better, seems to be key to success for getting these models out into production and getting them, doing what you need to be doing for your use cases.
So given that, Francesco, let's jump to you. But what are the biggest mistakes or issues that you see organizations kind of routinely encountering? Help, give people some advice here and a little bit of what should I be avoiding?
I don't even know where to begin. No, okay. So having tried the path of bringing from academia kind of models like verbatim and or adapting them to data, right? So there are just innumerable perils, right? Certainly, as Misha was saying, right? So moving to realistic data and like having an emphasis. You have a development team generally at your service, right? So when you actually bring models into production or when you attempt to, right? So again, like shifting the focus from performing model selection and really kind of model refinement, right? So the emphasis should really go towards bringing in the domain expertise that allows you to evaluate whether the data you have is even reasonable, right? So as in that's really kind of one of the most kind of critical issues that I see companies actually do kind of over and over actually when they try to actually bring machine learning into production, right? So as in they allow, for the lack of a better term, essentially they allow the data science team to rule the roster, right? So with let's say only kind of slight participation from the people who actually are going to use the outputs of the predictions, right? So we deal with generative models that are kind of particularly kind of sensitive to this, right? So where, again, the presence of kind of strong hands in terms of oracles and or kind of, again, humans in the loop, we'll talk about it later, right? So it's absolutely essential, right? So in my opinion, again, certainly one of the largest mistakes that people can do is to not essentially bring in the correct type of domain expertise to vet that the data is even contains the features that are desirable for what you're trying to model, right? So, and insisting on switching over to the next best model that you see in the latest kind of paper out of archive, right? So instead, and just to actually lower your loss, right? So instead of just really understanding if the model is actually extracting the right suggestions and recommendations, right? So again, there's a lot more to come, but certainly this is one of the most critical aspects that I see industry fail at, quite spectacularly often enough.
That's interesting. You talk about domain experts and people being fundamental to this. I guess that kind of leads me to my next question, which is, when we're talking about data, are we looking for volume? Is it a scale play? Or actually, are we looking about accuracy in terms of labeling and annotation? Zach, if I'm right at the coalface and starting my AI initiatives, what should I be looking at in terms of criteria for accuracy within my data?
Yeah, so at its core, obviously, accuracy is always super important, and the reality is, you said scale versus accuracy. You can't have one without the other, right? So because you have subject matter experts who understand the data, there's only so much labeling and management of that data that a single individual can do. So they can maybe process one data set, but if you're talking billions of rows and you're looking through that, they're going to be tapped out. So what happens when data set number 2 comes in, data set number 3 comes in? So I think you have to always have that balance in your organization around how much can we effectively process, and can we test and iterate? I think that's the other kind of area where, especially coming from my background, I work in customer data. It's always changing. There's always new fields. There's always new labels. And so if you approach it with this, we're going to do it now, we're going to have 90% accuracy on our label, and then stop and never come back to it, you're going to have drift. Eventually, all those labels are wrong. People change. They've added new fields. They've deprecated because you're not talking to the end user, that subject matter expert. So I think it's less around picking an abstract and arbitrary kind of metric of what is accuracy. It's what matters for you guys. How fast can you iterate? How many people do you have currently? And then work through that in a kind of a logical plan to come back and check and test and iterate over time.
So Misha,
if I can respond, Zach, to that too. Just one of the things that you mentioned at the end. I don't think we focus on use cases enough most of the time, right? We jump right into, do we need size? Do we need models? And oftentimes we skip the point where we're actually working with those business users and figuring out what problems they're actually trying to solve. Because like in real estate world, for example, there's very few big data sets. It's really thick data. It's a very different problem space, right? In healthcare, it's a completely different set of consequences if you get something wrong. And if you don't have a good understanding of what good looks like before you start to answer those questions, how do you get to the end effectively?
Let's double down on that a little bit, because Francesca, Misha is saying kind of emphasis on use case kind of creates focus, drives us to an end goal. I would agree with that, but I'm speaking to you from the UK, and obviously I'm subject to GDPR in my business. That is to say, privacy and data management of customers and end users. Francesca, what's your take on having some governance around ensuring that even if you don't live in the UK and maybe you're subject to California privacy policy, or indeed kind of whatever regulation that your industry has to adhere to, how do you accommodate that with good governance?
So that's a really great question. So we deal with very scarce data sets ourselves. Again, we operate in the world of construction, as construction documents and building designs, right? So that we can generate automatically. That's kind of our domain. And so in that sense, actually, we do deal actually in a very highly regulated and confidential data set kind of scenario, right? So, and certainly different geographies and regions around the world have different regulations actually on this, right? So, of course, data segregation is important actually to also certainly to comply to the regulations, but then the challenge actually becomes on how to use effectively this data for a purpose of a unified decision-making procedure that you're trying to do, right? So, and therefore, actually, what we see working is essentially augmenting your data, right? So essentially creating specific models that use in the specific jurisdictions the knowledge that is available, the data points that are available actually in those jurisdictions, right? So, and ensuring that you have a very, very strong policy on data augmentation that can extract essentially from a relatively small or smaller data set a larger pool of like labeled and correct, like valid data, because it's you manipulating it, right? So, and then aggregating using transfer learning essentially after the fact, right? So the problem with governance is that, again, sometimes again corporations that kind of bet the farm on having access to these data, like really as a matter of survival, right? So, or to actually obtain the right level of generalization in the models, right? So sometimes they overlook these challenges, right? And so they don't plan to curate the data this way in advance, and therefore actually they can't really accumulate the data set that is large enough and is meaningful enough to train the models that they plan to train, right? So they have to really kind of think about the data availability, and really if they have to create policies around, again, training multiple models out of segregated data and then essentially accumulate the knowledge after the fact. So this actually kind of harks back to conversations about ontologies, let's say the old days of AI, right? So, but there's definitely prerogatives and strategies actually in there that can be used to leverage those techniques, right? So it's certainly in presence of these constraints, right? So that are very, very tricky.
Well, and Lee, let me jump in on one interesting thing there is as we're thinking about labeling, and when you talk about governance and customer data and consumer data, that's a great opportunity to start thinking about things like exploratory data analysis. We actually within our platform have a model that actually dives deep in and looks for PII data. And very inevitably, we have customers who will come and say, "Oh, there's no PII in this one. It's good." And then buried in some JSON file, 4 layers deep is an identifier. And so being able to now use AI to even start the process and say, let's classify which ones are protected, which ones are not, and then go deeper and build models or be more kind of exploratory on them once you have that. So I think there's ways we can kind of stack the value of AI and ML, not just the end models, but even to prep and get the data ready.
Misha, what's your sense of what's the state of automation in all of this? Because it feels like we need to label this data, but to Zach's point, it's constantly changing. So what can we automate? What can the machines do versus what do I need humans to do?
I think for us, it comes back to what's the impact of the model you're building. The lower risk the model, I think the more automation you can test, as long as you've got strategies to look for drift, to make sure that your data sets are being tested for bias, and that that's not getting generated in the way that you are automating. So it's very, very easy to synthesize data or create automated labels that make your models look great, but they're chock full of bias and the data sets are unbalanced and they're giving you, best case scenario, bad results, worst case scenario, things that are, damaging or dangerous. And the nuance is really subtle.
Francesco, how are you surfacing bias and mitigating for drift in your business?
That's a really excellent question. So it's of course, the more constraints you have on the data that is available to you, and the harder it is actually to mitigate for that, right? So certainly it all depends on the use case, right? So we go back to that, right? So not all models have to generalize extraordinarily, right? So essentially, it really depends on the specific case that you're actually shooting for, right? So in our case, actually, our models actually have to be very precise in very prescriptive scenarios, right? So therefore, of course, we need to account for bias, right? So, but at the end of the day, we use generative models to, let's say, spearhead the exploration of actual solutions, right? So we cannot actually use generative models directly to produce, design drawings because of, hallucination, because of all the prerogatives and the features that make it hard to detect when essentially a generative model outputs something that is, phenomenally incorrect, right? So especially when the data set is limited, right? So that you're actually training for. So what we try to do is, again, insist on data augmentation and synthesis, as Misha was saying, right? So we try to pay attention, essentially predicting the types of features that the models will insist on. We try to synthesize with strategies that make that feature selection as diverse as we can possibly get. Of course, there's a limit, right? So especially when you start with a limited data set. But yes, we base most of our strategy on very careful, essentially, choice of synthesis methods, right?
Zach, is there a smarter way to do this? I mean, most folks seem to be scraping the web looking for data, but is there, a set of best practices for building data sets that's a little more less painful?
Yeah, I mean, I think, the reality is we're going to keep the same use case. I think this is going to be the theme of this webinar today, and a lot of it comes down to what is the end result of the goal, because there are so many good models out there and there's great training data sets. So you can there's resources, whether that's through partnerships where you buy them, whether you're working with a vendor, a data vendor that you're adding enrichment data to your existing data, scraping data if you need to. I think the reality is a lot of times, or at least the way it used to be, I think it's getting better, is everyone jumped into like, hey, let's get a model running. So they would go out and find all this data and then force a data set into the model and then kind of try to come up with something. Now it's like, what's the metric? What are we doing? And often, especially in the customer side, especially in the customer world, we can get away with a lot less data and a lot less features and a lot less, pieces of the model than you might kind of first thing. So I think if you start to be smart about what that data needs to output, and then go and find data to kind of augment gaps, either in accuracy or gaps in output for scale, then you don't have to go and just scrape the entire web for every customer demographic that you've ever wanted to find.
If I could piggyback off of that, I think it's really useful in any organization to have individuals or roles that can speak data science and can speak business at the same time. And to the extent that, right, because if you then start to look at, things like how good does your accuracy need to be, or how effective does your algorithm need to be, you can start to look at data sets as a factor of which data set do I invest to get me the outcomes that I want, and how can I upgrade over time, and what are the implications of that. So really starting to look at data sets as assets rather than just something you grab to make the algorithm work, think is the way we ought to start thinking about this, especially as data becomes more interoperable and models become easier to deploy and everything sort of starts to flex a little bit more smoothly.
So that's interesting you say that, because my next question was going to be around, how do we handle different types of data? And should we treat each data set equally? Should there be segregation to the likes which Francesco alluded to? For example, if I'm in computer vision for autonomous vehicles, I pick that as that's none of your industry. If I'm in that industry, then obviously I'm doing a lot with very unstructured data, images, but I'm also kind of leveraging some more straightforward kind of texture and maybe vehicle information. That's a lot. That's a lot. Storage itself is a challenge, and let's not even get started with edge environments. So how do we handle that? And from your perspective, how do you start? So we get a lot of practitioners watch these webinars. They're right at the beginning of their journey. What would you say that is a good approach for them when they're trying to handle all of the different types of data at their disposal? Francesco, I'm going to throw that hot potato to you.
That's a great. So that's also a great question, right? So I mean, this is not new, right? Obviously, right? So large data sets and managing them and handling them, regardless of the application, but machine learning is essentially one of them actually, is not new. And people have actually dealt with infrastructure like for computer science days, up to now in terms of machine learning, right? So how to deal with them. I mean, I don't think there's any kind of silver bullet. There's no kind of system that is ubiquitous and kind of homogeneously deals with any kind of format at the same time, right? So, but certainly in terms of mitigation, I think people have to plan for really kind of what is the representation that they need, right? So essentially, kind of what is the most salient representation that they need to feed their model with. I mean, we've seen some extraordinary advances, right? So like 10 years ago, people wouldn't dream of encoding in a vector, a sentence, right? So as in like the evolution of the representations of your inputs and outputs of especially unsupervised models, right? So it has actually come really long way. So something that the people have done fairly successfully is really trying to extract the most salient features. And in fact, that some machine learning models and techniques exist just for that, right? So that allows you to essentially, let's say, pre-process your gigantic data and essentially extract a more compressed version of it. Compressed, actually, of course, is a placeholder term, right? It's a general term, but just to say that essentially extracting essentially salient features that you can then retain for future kind of training purposes. Because honestly, if you're not like Tesla or Amazon, right, so you can probably hardly store, to your point, that even the mountain of data that come even from a LiDAR scan. Like sometimes actually it's literally, you hit really the transport the data problem like very fast, right? So and never mind store. So I think that that is actually definitely a way to plan for it, right? So essentially plan carefully the data representations that you need, the ones that actually accentuate the presence of the feature that you want your models to actually see, right? So down select essentially the specific portions of the data set that actually have the highest probability of generalization for your particular use case, and then essentially start from there. And that's really kind of all I saw that could work, right? Again, various forms of compressions also, actual data compressions also exist, like for actual, right? So, but generally it's really about essentially doing, let's say, a two-step process. I've seen it work actually several times, right? So filtering the data, essentially some down selection, right? So, but then pre-process it in a way that meaningful features are extracted in a more compact kind of fashion that is ready for you to ingest in essentially the form that you like, right? So that your model actually wants, right? So, and then store and manipulate that instead of the raw, essentially, right? So just the raw data sets.
Zach, you kind of touched on this earlier, but assuming I get through all these issues and now I have the perfect AI model, it's the best one ever seen, and it gets deployed in a production environment. And then there's this thing called new data that emerges and the model starts to drift. So how do I kind of manage the updating of the models as new data becomes available and suddenly my perfect model is not so perfect?
Yeah, so maybe I know this is a fairly technical crowd, but I'm going to give an answer that a lot of the technical people don't like. It's a people problem 99% of the time, right? So when we think about teams and organizations and we want to be nimble and we want to be agile and so we want to build the best model and then let it run and don't let anybody mess with it, right? The reality is, in practicality in a corporate environment, in a business environment, there are a lot of people involved. And having things like data centers of excellence, having data dictionaries, having tools where everybody's at least talking on a regular cadence, saying, here's what we're collecting. Oh, by the way, we're building this new partnership. It's going to mean this new data, or we're going to change. Often some of the more detrimental is not necessarily adding new data. It's deprecating data, right? So we had this partnership, we had some data. Oh, by the way, it's all going away. And now your model is going to have to be, rethought, or at least in the customer and the corporate environment, that happens, quite often. So I think the trick is step number one is having robust kind of people processes in place. So you guys, so teams can talk, be aware and share that knowledge of this model's working. It's based on this. All of a sudden, oh, it's going to change. What impact is that going to have? Do we need to test? Do we need to iterate? Do we spin off a secondary version of that model and test it with the new data and compare, right? So you have the production version and you have the new iteration, and you can run those side by side. What's that impact? And so I think at the end of the day, if it's a production enterprise dependent data model, things don't happen in isolation, and they shouldn't. So focus on the people side, and I think a lot of teams will have better success.
I'd like to interject that. Actually, Zach made a phenomenal comment here. So I think I completely agree that it's a people and process issue, if you will, right? So, but for me, it actually seems to stem from the fact that data science and using machine learning at large in production is still relatively new, like certainly at the level that we're talking about. So there are some, let's say, very solid engineering practices and like product-oriented practices that haven't quite made it all the way back, right? So I mean, to the point, a part of this conversation is about that being data-centric, right? So, but just like your product, your new user interface feature actually has to go through A/B testing, it has to go through a whole lot of preparation and understanding, right? So before it actually goes into production. That has to start with the data, right? So the data itself actually has to go through these iterations, right? So never mind the models, of course the models too, right? So, but the data itself actually has to be a product and a byproduct, right? So it needs to go through processes that are informed by people in order to ensure that the right data is deprecated, the right data is actually injected. Do we need a whole new model, or do we need a transfer learning model? There are some specific questions that only like a good analysis of the data can do, right? So, and to your point, essentially having strong people processes that instruct that is really at the heart of the issue, right? So people just don't do that enough.
So Zach says people, and Francesco says kind of iteration and management of your models. From my perspective, Misha, I've seen a shift in influence of the data engineer. That is to say, the data scientist and the data engineer have become more definite roles because of the division of labor. But we're also seeing the emergence of new roles. So data product managers, for example, who are part governance, part product development. What's the next step? Where are we going next, particularly kind of with generative AI and foundational models? What's the skill set that is going to allow us to kick on to the next level of the production?
Yeah, it's. I think we're going to see more proliferation of kind of separation between roles like data engineer and data scientist, but we'll also see machine learning engineers becoming more distinctive. ML ops is increasingly something we're seeing, right? And then I think the thing that generative AI will bring is prompt engineering and specifically labeling. Like there is a whole organizational sort of capability that organizations are going to need to build around labeling, engineering, prompt engineering, and that kind of thing to enable some of these technologies to work in the long run.
I also see a growing demand and kind of result of the whether you call it a data strategist, a data technologist. This is kind of the person who sits between IT and data and the data science teams and the business teams, who understand enough of both worlds to be able to kind of be the translator. We had that in MarTech and IT for years. We've had that in many other places, product and engineering. And I think data is the person who can label and understand data, but at the same time then go sit in the C-suite and have conversations about the impact of it.
Yeah, not to mention, by the way, sorry, just to add on to that, what are the changes in the way everybody else's roles are going to be impacted, right? Finance is going to have to figure out what the cost of maintenance is for a model, because it's very different than the cost of maintenance for for software. Same as legal. Think about the legal implications of licensing agreements and residual data removal and all of those kind of things, right? So the effect is going to, I think, go beyond data science and ML specific roles into really the broader organizational abilities.
extremely application dependent as well. Right? So as in like the use case actually is king there too, right? In these implications. So
Francesco, what are you looking for in a data engineer? Because, not to be overly cynical, but there are some folks out there who were, they were doing extract, transform, and load ETL stuff for data protection, and now suddenly they're data engineers, and it's a brave new world. So, what are the attributes of a good data engineer, and what skills should they really have?
again, I think it's in the name. It's like data engineer, right? So I expect process, right? I expect like rigor in analysis, right? So it's not, it's not an IT job, right? So it's not just a systematic kind of functional skill, right? So it literally is a deep, requirements analysis. It requires the types of process and expertise to recognize the appropriateness of a particular process to bring data to production, right? So to bring data and the relative models that are fed this data actually to production. So this is again, it's a let's say migrating off of. To your point, Mike, right? So someone who just, receives the data, just prepares it, and just essentially does kind of light touch, and then kind of feeds it, shoves it to the to the data science team, right? So again, someone with a data engineer kind of a moniker or a connotation, right, really actually needs to step up to the next level of, again, MLOps, right? So to really kind of systematize not just the ingestion, but the preparation, the extraction, the filtering, the staging, right? The staging of the data. That's at least kind of what I see in a data engineer actually as a fundamental requirement, the process.
Listen, this wouldn't be an AI webinar without summoning the bogeyman. So I'm going to do it. Tell me, what keeps you guys awake at night? Is it data monopolies? Is it kind of false use of data? Is it data leakage? Is it cyber attacks? What are the areas where you don't want people pushing your vulnerabilities? Zach, you want to take us on that one?
Sure. So obviously, being in the customer space, PII and everything surrounding PII is always, top of mind. So governance, control, access, and whatnot. But I think the kind of the under the surface or the under current that I think is a big issue, especially in the customer world, is bias. Because a lot of our models are based on past behavior of customers that may not be indicative of what the future model is, and you're not working on a representative sample of the population, right? So you can't to kind of go in and say, well, we're not going to have bias. Inherently, there is bias there. The question is that bias harmful? And I think that's a harder question to answer in a lot of situations. Smaller companies, maybe not as much. Larger companies, maybe a lot. And whether it's from hiring, right? Where do we put a new store, and who do we hire for that new store? And if we're building a model based off of that, it might be a sound business decision, but it might be inherently limiting a population. And so I think that's an area where there's a lot of opportunity to have conversations. The problem is sometimes those conversations are hard and scary and difficult and challenging, and so they kind of get ignored. Or there's other more pressing, fire burning type problems, and so again, bias becomes kind of a secondary thing. So I think that especially in the customer data world is one of those areas where it's eventually going to bubble up in a bad way at some point, and going to need to be dealt with.
Yep. And Francesco, should we be marking our own homework and mitigating and moderating for this, or should be challenges that Zach describes, should this be regulated by an external source? Where do you sit on church versus state and all that?
Well, that's a tricky question. So, no, I mean, I don't deal with PII. Like, we don't deal with PII data. So, but nevertheless, essentially, we are still in a highly regulated kind of data sets environment, right? So, and yeah, bias actually is certainly a strong argument, actually, a strong issue, actually. It is the one actually that keeps me up at night. Bias versus, expectations of users of these models, right? So, essentially, so, and I think it is difficult to understand the type of organization that could regulate from the outside, because sometimes it's like your secret sauce, if you will, like the secret of your own competitiveness as an organization kind of relies on the intricacies that lie literally at the forefront of your data and the models that you choose, right? So, or your secret sauce at data augmentation, right? So the tricky part is really to invite essentially kind of external third party to evaluate essentially the bias in your data without giving away too much, essentially. And so that is actually definitely. Well, having said that, of course, again, we go back to the application area, right? So there are some specific, like as in, if an organization uses AI to create their marketing campaigns, and they spend the wrong amount of money in a particular region, in a particular quarter, right? So because that was the suggestion. Well, I mean, of course, it's a problem, right? So it may be, bias. It may be because of bias, right? So the data that inform that decision, I see that as not impossible to have it under scrutiny by an external party, right? So, or if that's really kind of the secret sauce of the data provider, then by all means. But in certain circumstances where the decisions are much more critical, right? So then, of course, the discussion of church versus state is kind of more biased in one direction, right? Pardon the bias pun. But what I'm saying is that just like several industries are heavily regulated, right? So because of the criticality of what they are expected to provide, right? So there are certain facilities and functions, the usage of insurance, for example, right? So their models, their actuarial models is certainly one of the secret sauces. Having said that, the insurance companies globally have the power to influence the economy so vastly that zero oversight on how those models are created or trained. It's a potential for catastrophe, right? So in the grand scheme of things, right? So again, we go back to the application area, right? So there are certain nuanced application areas where I would definitely invite more scrutiny for bias, right? Certainly.
If I can tack onto that, it seems hard enough even for fairly technical folks to understand what's going on with models and with the process it takes to bring models to production. It seems like it's going to be infinitely harder to get lawmakers to understand those intricacies. I think just as a self
probably won't stop them trying, though, Misha. That's the problem.
That's right. I would love to see us have something tantamount to like a Hippocratic Oath for AI practitioners, where we really take to heart a code of ethics that helps us protect outcomes for society in a way that can build a little bit more confidence on the regulator side and protect us a little bit from well-meaning regulation applied to technology that's not well understood.
I think, Misha, you'll have a strong. Sorry, Zach, to interject. There's one only on touch point that I want to just make, because I think it's really important. And we do have the Damocles sword on our heads, which is government regulation, essentially some external influence that essentially legislates essentially what can and cannot be done, and certainly actually at some point is. But I would certainly rather preempt any of that with regulation, self-regulation that is surfaced and be made very apparent and transparent, than essentially holding our cards close to the chest and wait for the legislator to come and take their completely uninformed position and essentially using the wreck ball actually on the industry actually like that. GDPR, it's very sensible, but right, so it's not influential, and it just came from the sky, right? People could foresee it happening, right? So, but it just happened at some point overnight, right? So, and people are like, okay, what now, right? So,
yeah. Sorry, Zach, go ahead.
I was going to say, I foresee a reality where we need and will need to have a third-party audit system, not legislative driven, but more like you see in cybersecurity, more like you see in IT organizations, where we can have our processes and our rigor and our tools audited and have that as some sort of, because we see that in other areas. We see it in publications and magazines and newspapers when they had to go and they were charging advertisers based on circulation, and so they would get audited. And I think that helps keep lawmakers out, because there is that that intermediary. So you can still set rules, but they shouldn't be the ones counting our models. The lawmakers, it really should be, But I think there's an opportunity for transparency within organizations to say, we've had others besides us look at these models, and we're trying to be good, if you would.
Zach, some organizations establish standards, right? There's ISO standards. There are industries of any kind, right? So create standards that determine that the process is solid, right? So without necessarily kind of looking at every row in your data set, right? So just like we can make airplanes fly because there's a process for determining that an engineering process sound, if you will, then they fall out of the sky. But that's a different issue, right? So, but what I'm saying is that there should be like practices that are established, and regulators and or agencies, up and running to perform those checks for compliance, right? So at least on the standards, right? So if not exactly on the data, exactly right. But again, to your point, that the data is actually a critical part of this equation, right? So there should be probably someone actually to check for the compliance of the data itself, right? So, or to have a measure, right? So measurable.
All right. Hey guys, we do have a question, but before we get there, I want to close this out and just point out one thing. Based on the number of so-called doctors pushing bogus cures, an oath is not going to cut it. The issue that I would also kind of point out here is one of our attendees would like one of you, and I'll accept volunteers, just to explain what is the deployment model for AI and ML, because in the land of DevOps, we have dev and stages and production and those flows. Is that the same thing that applies to here in the deployment of AI models? Is that what an MLOps process is? Dak, you want to take a shot at this?
It should be. It should definitely mirror, a more kind of DevOps process where, you start with, a kind of a dev environment and kind of work through, the messy part there, and then eventually, as you get to the point where you believe it's ready, you move it into staging, where you can do QA testing, you can do user acceptance testings, you can start to you do some A/B testings against maybe existing models in place, where it's not live yet, but you can validate your models, and then ultimately move that into production when those checkpoints are in place. I don't know that it happens in practicality that way as much as it should. I think sometimes it may even be just you're building the model locally, and then it gets pushed into some production instance, but nobody uses the data until it's ready. But I think that's the maturation of the of the industry and of the space as we get better, and as these models, as Francisco said, as these become more readily available in an organization, as they become used and become mission critical, we have to apply that rigor and that structure to the process, and work with teams who are experts at doing that, right? You have those DevOps teams who already know how to run continuous development cycles and whatnot. Partner with them and start to think about what are those processes that can be implemented.
There is one gotcha, I think, that is worth stipulating here, and why it seems like MLOps is a burgeoning and distinctive role, and that's it's really hard. It's very different to bring software into production where you can replicate it from environment to environment, than it is to bring a model where the data is constantly changing, and you don't necessarily work with the same data sets from environment to environment. So repeatability is a real thing. And hard to accomplish if you don't think through it right. So that's the gotcha to watch out for in your deployment pipelines.
Misha, we're seeing a kind of a subset of ML ops is data ops, for one of another bandwagon to jump on. But is that valid? Is that the point of deviation between ML ops and DevOps, because it is so more data centric?
From my opinion, I think it's a title thing and a capabilities thing. It is somebody in a position to understand the impacts of maintaining repeatability or other implications for bringing a model to production. And that could certainly be a DevOps person, but that doesn't necessarily mean that it's automatically something you can switch on and get a DevOps team to start deploying models successfully.
I have a comment, actually. Sorry, Mike.
So go ahead. Yeah, go ahead, Francisco.
Okay, thanks. I was just going to say, I think, to your point, one of the differences that I also see, as we were actually talking earlier, right? So, is that critically in MLOps, there's data, there are the models, and there are the products, right? So I think there's this, let's say, extra stage of federation, of curation, of engineering that is not really, present in, let's say, DevOps, let's say in traditional, software DevOps, right? So, of course, there are nuances and potential similarities, but both the data and the model are so critical, actually, and distinctly so. They're orthogonal sometimes, actually, to each other. Sometimes they're not, right? So, but essentially, there's this extra engineering step that is quintessentially MLOps, right? So the practices that have been already kind of well established and well oiled for, let's say, software DevOps may need some tweaking to cater to the fact that data federation, for example, it has to happen, right? So possibly even in isolation of, again, model refinement, selection, and deployment, right? So I would just my 2 cents, right? So I haven't seen it done systematically. That's the thing. I have not seen it done systematically.
We may need a new buzzword, because I don't think Dev ML Ops rolls off the tongue.
Spectacular.
We'll work on that. We have another question, though. I'm going to throw it at Zach. Is there a good data set size for machine learning? Is there a minimum that you should have, or is it always going to be a case of depending, or for that matter, is it always kind of evolving? Because sometimes, depending on the use case, different data sets work for different things. What's the state of the art?
Yeah, I always hate to answer a question with it depends, but I think this is one of those it absolutely depends. And I'll give you an example. If we just do in the customer role, a propensity to buy model, a likelihood of a customer making a purchase, you have to have a data set that's of past purchase behavior that's big enough to take out things like seasonality, to take out things like the fact that the pandemic happened and people's buying behaviors changed. And so you have to think through there's a data kind of lens, but then you have to think of the real world lens of what are you trying to predict. And so take out, buying holidays and enough customers that it's representative. Because if you just said, hey, I'm going to take the last 3 months of customer buying behavior and use that to predict everything in the future. Well, in the last 3 months, we finished the kind of Christmas season, is that included or not? Because that's a big buying change in retail. So I think taking some practicality to your world. Now that wholly changes when you start thinking about generative and different things, because I think there can be some more abstract. But when you're so it comes down to use case. But when you're thinking about what are you trying to achieve for or account for, then you have to find a data set that is representative of the outcome you're trying to predict or model or produce.
Couldn't agree more. So, but let me add that again, it depends. I will add that it depends. So, no, what I mean is that the application area again, right? So is of critical, paramount importance, right? So especially if the models that you're trying to create and deploy contain specific variables that in advance, to Zach's perspective, right? So as in this is something that you can extract and you can predicate from, or include, essentially include in your modeling in such a way that even if you only have a small data set where you know these variables are going to influence that data set, you can extract that, right? So you can extract that behavior and model it separately, right? Or critically invariants, right? So look at something like physics-informed neural nets, right? So you're not trying to invert matrices necessarily, right? So you're trying to approximate the solution of a physical system, for example, right? So, but you're not trying to necessarily teach it all the physics, right? So you're only trying to learn some specific nuances because you already know the other formulae. Those are well known, right? So the size of your data really kind of varies depending on how many assumptions you can make about the system that you're trying to model. Right? So the more the variables that are known, the more the invariants that are known, the more you can extract them out, and the lower is your need for a fast data set.
I agree with everything that's been said. It's really important to have a representational data set that's balanced. And one thing I beg everybody on the call to do, if you guys are building models, don't just look at the accuracy metrics. Look at what it's actually predicting. Take a sample and put your eyes on it and see if it makes sense. A lot of the times your models are going to look great and the accuracy looks great, and then the results are just, they're not giving you what you need. And chances are that's your data set that's imbalanced, or it's looking at too short a time frame. And that's, I think, one of the ways you'll know if you've got the right data set to start with.
For example, have your domain experts look at the features, right? So essentially, sometimes actually, especially with some types of models, I mean, again, many models are, imprescrutable, black boxes, right? So that are, alien to all of us, right? So, but sometimes it's actually possible to kind of, peek under the bonnet and see kind of what features they learned, or I mean, they pretend to have learned, right? So, and a domain expert can take even a look at the features and say, well, learning this makes no sense. Like, as in having a kind of concentrated attention on a particular feature may be completely meaningless, and that can tell you something about your data, right? So, or the model, but certainly about your data.
Let's bring it full circle. I'm sorry, go ahead, Lee.
I was going to say, good counsel from Misha and Francesco. I think Mike's got a doozy teed up, so I'm going to give it to him. What's your question, Mike?
So let's bring it full circle. We started out with this disconnect between the business and the people building the data model. It seems to me, and surveys have indicated this, there is this tendency where C-level execs go hire that data science team. They put them in some sort of little ivory tower somewhere. They come back with data sets and analysis that don't align with the business. The rest of the business, shakes their head and says, well, that was a waste of time. So are we in danger of some sort of backlash against AI investments because we don't have the right data set models in place and the fundamentals aren't really sound enough? And maybe we just need to take those data science guys and put them in the middle of the floor and surround them with business people. Zach, what's your advice to folks?
Yeah, absolutely. I think, it happens. We see it happen where, you have a data science tiger team that goes off and, produces something that's irrelevant, or not necessarily irrelevant, but maybe misinformed. Right. And so I think the reality absolutely is just like I love analogy. So just like rogue IT, where marketing went off and bought some tech and thought it would work, and then all of a sudden they're like, "Wait, why isn't this not integrated with anything?" The reality is happens on the same on the AI side, right? Is we've got to go and work as a team, think through where your experts are, share that knowledge, because ultimately there's a lot of value that comes with not even just building the model, but it's looking at the data, hypothesizing around what could we produce? What's the outcomes? How are we going to use it? What is that impact of, as Misha said, right? What does that accuracy matter if the outcomes are wrong, right? So yeah, it's a highly accurate model, but it predicts something that's not really relevant to us, and or doesn't play out in the real world. And so, so absolutely, I think anytime you can have a data center of excellence or a team, you're always going to be a step ahead. And if you're on a data science team that you're kind of hidden in a black box team, push to get in front of the business, push to get in front of it, because you want your models to be used. and you can influence that. Executives don't necessarily do this out of malice, but a lot of times just they haven't seen the failure yet. So push to be the one who says, hey, maybe we should talk to the users of this data.
It's always more successful like that, regardless, Zach. You're completely correct. Like, as in, if it's the data scientist going out into the business and actually conveying what's going on, right? So why are we doing this in the first place? Why do I need to know what you know, right? So it creates that kind of bond that I've seen not happen everywhere, right? So, and that's where, again, there's catastrophic failures where people are segregated in in a room, and they business expects wonders out of them, and then just nothing comes out, or very little, right? So it takes leadership to do that, right? So it takes mandate from the leadership to say, listen, the first 6 months after you hire data scientists, you send them into the field. You just send them to the business and shadow what's happening, what we actually need, right? So no TensorFlow, no PyTorch, no Scite, just no Python at all, right? So no data, just look at what the business does, what we need to get out of an analysis of the data that the business has and produces, right? So, and then start going down their modeling route, right? So
it helps, I think, to actually have a data strategy written down, a senior level executive driven data strategy. And exactly. And that'll keep Tiger teams to a minimum, get them in the thick of things. To Mike, to respond to the other side of your question is, do we see investment cutting back? And I thought that was an interesting question. The way I think about that is, you're going to have folks that get burned, and they might think twice about doing it again, but their competitors may not have gotten burned. So I think the market's going to force folks to either lean in where those use cases make sense, or they'll see other folks come in with competitive advantages that can deploy. And that means maybe the spend shifts to organizations that have figured out how to do it right. But certainly with as much excitement as generative AI has generated at the broad level, I can't imagine a world where we go back up the hype curve.
Yep. Lee, we got a couple of minutes. You want to have some closing thoughts?
Yeah, so great thoughts and counsel from you guys. If you want to succeed in the Darwinism of this industry, then get your people involved, iterate, have guardrails. Great point from Misha about compose your data strategy right from the get-go. But as always, people eat strategy for breakfast. So get your people involved and make sure that they understand that. Great notes, guys. Great notes. Listen, with my AI fairy hat on, I'm going to grant you one data-centric wish to remove friction in your organization and accelerate your success. Tell me, what would the one thing that I could grant you be? Zach, you want to go first?
In 10 words or less, folks, because we're running out of time.
You know what? I just more access to the entire team, so they understand what data is even available.
Francesco.
I echo Zach, actually. So again, broader perspective for the team that is actually going to use the data for whatever the purpose is. Right? So,
Misha.
I'd love to see our clients get their data people right in front of those business problems.
There you go. As always, folks, hey, thanks for sharing your knowledge and insights. I'm going to hand it back to Cody in a minute, but I would just point out the best piece of AI advice I ever heard and still remains is, it's one thing to be wrong, it's another thing to be wrong at scale. All right, Cody.
Awesome. Well, Mike, thank you for that. And Lee, Zach, Misha, and Francesco, thank you all so much for being here today. I'd like to remind everyone that this session was recorded. Should you want to rewatch or perhaps share this, you will be receiving an email with a link to access the recording on demand. Or, of course, you can find this living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. The 4 winners of our $25 Amazon gift card giveaway are Haney T, Selva K, Daniel Z, and Jose T. So to our 4 winners, congrats. Keep an eye on your inbox to claim your gift card. You should receive that email in about the next 48 hours. If you don't happen to see that email, please do check your spam folder just in case it gets filtered out. I'd like to thank the AI Infrastructure Alliance for sponsoring our program and bringing these speakers together. And to our audience who has been here with us for the past hour, thank you so much for attending. We really value your time, and we want to hear your feedback on our program today. So as soon as we close out, there will be a survey. So feel free to fill that out. And if you'd like to hear more from the AI Infrastructure Alliance, there is a question on there where you can request some more information. Otherwise, we hope to see everyone at a future TechStrong learning experience. Have a great rest of your day. And to our panelists, thank you all once more.
Thanks so much for having us.
Thank you.